This is a quick video on section 5.1 related to simple interest. And I thought it'd be a good idea to go over one of the problems we went over in class today, and it's shown on the left side of the screen over here. This is from Learning Catalytics, and we're talking about an interest-bearing account called a bond, and the interest rate on this account is 3.3%. APR, and interest is paid twice a year. And this is the key part of the problem that we have to figure out what they mean by this. Okay, and the principal, the amount that the bond was bought for, is $10,000. Okay, and the question is how much interest paid out every 6 months. So the idea here is that we have several formulas that are coming into play. We have A is equal to P times 1 plus RT. This is the future value form, the future value equation. And then if you solve that same equation for P by dividing by both sides by 1 plus RT, this is the present value form of the equation, of the investment equation. And we just need to figure out which formula applies. There's also a formula for I, which is the interest paid, simple interest paid, on a principal P at an interest rate R for time T years, and that's given by P times R times T. So we have three formulas in this section in 5.1, and we need to figure out which one applies in this problem. Okay. The idea here is that one way to approach this problem, and I think the most straightforward way to approach it, is to realize that at time 0 something interesting happens, and that is that at 10,000, P equals 10,000, bond is purchased. And after T is equal to 1 year, right, that bond is going to be worth 10,000 plus the 10,000 times the interest rate of 0.033, which is the 3.3%, and for a time T of T is equal to 1 year. So that bond after 1 year is going to be worth $10,330. Okay, and that was computing interest once that year. Okay, so you earned $330. So I is equal to $330 of interest, earned in 1 year. Okay, the simple interest idea, since we are in the simple interest section, is to think of that $330 of interest being split out, divided up into two parts. So in the first half of the year, you're going to get the $330 divided by 2. And then in the second half of the year, you're going to get the other half of the $330, which is $165. Okay. So in the first 6 months, simple interest says that you've earned $330 in 1 year. So your first year, half of a year, you're going to earn $165 in interest, and then the second half of a year, you're going to get the other $165. So, which means that the amount that you're going to have after one half of a year is the $10,000 plus the $165, and then that makes the $10,165, And the amount that you have after the full year is going to be the 10,165 that you had, plus the other $165 to make a total of 10,330. Okay. So the answer to this problem is $165 is going to be paid out every 6 months for a total of $330 for the whole year. So they computed the full interest and then divided it into equal amounts. Okay. One of the ideas that we were trying to discuss in class, okay, is kind of hinting at the idea of what's called compounding of interest. Okay. And the idea here is to compare the timelines. Okay, so you had $10,000, and if you just did simple interest after 1/2 of the year, you were going to have 10,165, and then after a full year, you were going to have 10,165 plus 165 again to give the 10,330. So the blue line here, the blue values, are the simple interest idea. Okay. If we switch to compounding of interest, the idea goes a little bit differently, but still based on the simple interest idea. You still have $10,000 at the beginning. Okay? And what you're going to do is take the 3.3% interest that's been agreed on. So the amount in the future is going to be the $10,000 you have presently, plus you're going to compute interest once at the 3.3% interest, and you're going to get that for 1/2 of the year, which leads you to the same thing it did in the simple interest formula of 10,165. Okay, but that's the amount that you have after 1/2 of a year. The compounding idea becomes more noticeable when you go to the amount at the last of the year. And the idea with compounding of interest is you compute interest again. You don't divide up the interest over the full year into equal parts. You do a recomputation of interest with the 10,165 as the new principal, and compute interest a second time. So in the simple interest, we only computed interest once. Now we're going to compute interest a second time, and you're going to compute that interest on the new principal value of 10,165. You'll have the same 3.3% interest rate, but you will get that computed on the second half of the year, which will lead you to a value of 10,165, an interest payment of 10,165 times 0.033, and then divide that by 2. And now your interest payment on the second half of the year in the compounded of interest case is $167. Rather than getting $165, you're now getting $167, which means that you add that to the 10,165 to get a total amount of $10,332.73. So if you're computing interest in a compounding way, compounding meaning that you're computing interest more than once, you will get more money at the end of the year. If you compute interest only once, right, then you have $330 of interest. But if you compute simple interest twice, right, as we did in the pink case, compute 2 steps of simple interest where the principal is changing each time, then you can have more money by the end of the year. So that is just a pretty quick example about the difference between simple interest and compound interest. And it's important to remember or to pay attention to what is being asked in the problem. How is interest being computed, simple or compounded? And in section 5.1, simple interest is the name of the game. So in the next video, we'll look at a couple more examples of simple interest problems.